Sunday, here in the shop, February 16th. What are we doing today? We're going to work on the house project today, the Hemi, for the funny car. We're getting way behind, and man, it's already middle of February, and we're nowhere as near even thinking about being ready. Look like we ain't going to make the Gator Nationals the way things are going, that's for damn sure. But anyway, I don't know what we're doing today. Finally got a minute, try to catch up. Working on the cylinder heads today, finally. We were going to do a little short block work today, but we ended up finding an area on the block that needed some repair. So we sent the block over to Badass Brian, over at Brian and Mike's shop. They're going to do a little welding on the pan rail where somebody did a repair before where there was a window in the block and did a shitty job, and it looked like it was going to promote a leak on the pan rail area. I'll show you. I don't have a Hemi block here, but so we'll just look at this small block for a minute here. On the pan rail where the motor kicked the rod out, somebody repaired a section of the aluminum, welded it back in, and it wasn't very square. And I could see that it was going to do nothing but promote an oil leak. So Brian's going to heli arc that up. I'm going to bring it back, put it on the milling machine, and we're going to mill that down and get it nice and square. And then we'll clean it up and start doing the short block assembly. But in the meantime, Sunday, got a minute. I'm going to try to sort these heads out. So these are the Brad Anderson 5 heads we bought up in Mooresville. We paid $400 for them. Super deal, I thought. Little did I know, this Hemi stuff is expensive. Valves and everything special, and hard to get information on it. A lot of it's one of, as you can see, the Hemi, the Brad Anderson head, there's no part numbers whatsoever. So you're pretty much at the mercy of calling the manufacturer and having them either fix it, build it, or sell you some new shit. But we don't have that option. We're po around here, and what poor people got to do, we got to improvise, adapt, overcome, like the Marine Corps. There you go. So, trying to figure out, in this head here, Brian, such a good guy, I swear. He welded up the deck for me where we had a little torch action going. I still got to get up here and clean this up in the chamber, and then I got to remachine where the hoop goes. But he welded that up for me, and then we machined it down just to get both heads same thickness. But anyway, trying to figure out the valve situation. Haven't cut the seats yet. They're a little rusty, from sitting. They need some attention. Redo the valve job, but we need some valve train. So measured them up, and they run a 2-inch 400 intake valve, and looks like around a 1-inch 950 to a 2-inch exhaust valve. So just doing some thinking, and I said, wow, big block Chevys, that's what I normally ran. I got a ton of used big block Chevy parts, and of course it's one of the most common motors we work on for customers. So started going through some of my old parts, and had a couple nice sets of used valves that had really low runs on them. These are Titanium Excelodyne. Are they Excelodyne, or these might be Victories? Victory, okay. Victory titanium valves, top of the line stuff for a big block Chevy. Now these were for like a Pontiac headed big block, like your symmetrical port, like your common in like your Pro Stock or Pro Mod style big block Chevy. And if you notice the Pontiac heads that they put on the big blocks, they're super thick because they're rolled over candid valves, so they have to run a super, super long valve. So I said, well, the head will work. That's the right size. We could cut the 45. I could even trim up the head. These are actually 2-inch 500s, and I turned these down on the lathe 50 thousandths to fit the Brad heads. So we checked them out, and lo and behold, I think they'll work. The only problem is they're way too long for the installed height that I want to use. And a lot of the information, you guys watching these videos probably already know what I'm talking about, so it's kind of rhetorical, but just go with it, because maybe there's somebody that doesn't know, or a newbie's on here wanting to learn a little something. I'm going to try my best to make this half-ass educational. So I set up a retainer in the head here to see what the theoretical installed height would be. And what you're concerned with when you're putting the head together or building a motor is spring pressure, obviously. Solid roller cam needs a certain amount of spring pressure compared to a hydraulic or a flat tappet. Again, RPM range has a lot to do to pick out the spring pressure you want. You'll get many answers from people on what the optimum spring pressure is. And I really don't think there is a one-size-fit-all answer. So a lot of guys that run these big blown motors, Pro Stock style, high RPM stuff, use insane amount of spring pressure. More spring pressure, more wear. And I don't want to get in a situation where I need 3 sets of valve springs to make one outing at the track. I want the car to run fast, but I don't want to break a lot of stuff either if we can avoid that. So my thinking is, and I've had good luck with, keeping the valve train as light as possible. Lightweight valves, lightweight titanium retainers, even on some of the motors, lighter springs, smaller diameter springs. But I'm not going to chance that on this motor. This is a blown alcohol motor with a roller cam, and I got to take in consideration the boost getting pumped through the runners. That's another added stress that's going to want to open these valves up. As the valve's opening, the boost is pressing on them, wanting to push them back, so we're going to have to add a little spring pressure for that. But my thought is, I'm going to keep these valves light. I'm not going to turn this motor 10,000 RPMs like the pros do. I'm going to turn this down a notch. So I'm coming up with a nominal spring pressure. I'm going to set these up. Normally these guys run like 400 at the seat. I'm going to set mine up at 340 at the seat. 340 at the seat. And I'm going to use a pretty long spring because unfortunately these hemi cams got a lot of lift. The intake lift on the cams going in this motor we're building is 950. That's almost 1 inch of lift. It's a lot of lift. A lot as far as I'm concerned. Never ran anything on the circle track or the drag motors we built with that much lift. I'm actually going to back off the rocker arm ratio on the exhaust to take some lift away on the cam. We're running a 1:8 ratio on the intake. Like I said, makes 950 lift. And on the exhaust, I'm going to put a 1:6 ratio. That's going to take about 150 thou away from the lift. I don't think we need, all that lift on the exhaust. I think a little split is going to help it. And I'll get into my theory later on why I'm doing that. But right now, we got to work on these valves. And again, this is what poor people got to do. I had the valves from another application. You're probably saying, well, how the hell is this going to work? These things are way too long, and they are. Like I was saying, I want to end up with 2-inch 300 installed seat height. And I'm taking in consideration the thickness of the retainer is 100 thou. So from the bottom of the retainer to the bottom of the head, I want to end up with 2-inch 200. I want to run a shim because these are aluminum, so I'm going to put a hard 60,000 shim in here. So that'll deter the spring from bouncing and wanting to saw through the head, because you can't run that steel spring on aluminum. So what I want to end up with is 2-inch 200 on the other side of my 60,000 shim to the bottom of my retainer. And measuring what I have on the valves now, these long-ass big block Chevy valves, they're about 300 thousandths too long. So what we're going to do is we're going to put these bad boys in the lathe, and we're going to trim them up. We're going to take off what we need on the stem, and then we're going to move the key groove down and make these suckers work. Springs I'm using, Manley, Nextex. I got a brand new set from another build, and I'm going to set these up at, like I said, 2-inch 200. It's going to keep me about 80 thousandths from coil bind. Very important that you pay attention to where your coil bind is. The term coil bind is where the springs would stack up together. For instance, if I put this spring in a vise and squeezed it down to where all the springs would stack up and actually become solid and wouldn't move anymore, that's your coil bind. So you want to make sure whatever your cam is, like let's say you got a 1-inch lift cam, a 2-inch seat spring, and it coil binds at 1 inch. If you got 1 inch worth of lift, you're going to coil bind, and you're going to break stuff. So you got to stay away from coil bind. But there's a fine line. You don't want to be a mile away from coil bind either, because you want to get all the spring energy you can close to coil bind, because the more you can press this, the more spring pressure you make. So you don't want to leave any on the table by saying, oh, well, I'll just put a real tall spring and I'll keep it, a mile from coil bind. Well, then you're not getting that pressure over the nose that you need. Again, it's another answer. If you call different engine builders, there's there's no one size fits all. I found out over the years that leaving between 60 thou to 75, leaving between 60 thou to 75 thou coil bind seems to work the best for us. But anyway, we're going to put this in. I'll show you how we're going to do this. We're going to take some valves here. I'm going to go over to my trusty engine lathe. Every shop should have a good size engine lathe. And make sure you get a lathe with a good size hole in the spindle, because without that, there would be no way to do this. Try to get one of those phone stands. I'll tell you, it'll make it a lot easier. So what I'm going to do, has a big enough hole in the spindle that I can open the chuck up and actually put the whole valve in the chuck. Then I'm going to close the chuck up. And I'm going to chuck it close to the jaws. Closer I get, the stouter it's going to be. I said I'm going to remeasure. I think we figured either 300 or 400 thousandths we want to take off the tip of the valve. But what we'll do after we part this off, and then I'll rechuck it and bring it out, and then I'm going to grind the tool, and then we're going to rekey it with a new groove for the keeper slot. Stay tuned. I'm going to get these fired up and cut down and show you exactly what we're doing here. Again, this is how you got to do it when you're bucks down racer, and use what you got. That's crazy.
Yeah. And everyone, he get mad at me when I don't listen. When the man tell him, I need to do this. He said, that man, no. I said, well, it's a thing of, it's know-how, and he's been through it already. So he knows. I said, but I'm not trying to.
You're talking about the Robert
Hayes,
talking
yeah.
about
Robert Hayes, yeah. So he wanted me to put, he said I need 48 gears in my car. And I keep telling him, I don't have that much chassis. I got a mile. If I had a chrome Marley, double frame rail car and all that, I don't have all this shit.
What gear are they running David's car in the Patriot?
300.
A what?
A 300?
300.
Yeah. You already put a 274 in or something. You're gonna have to have one made, special made.
Really?
I know exactly what gear because he told me 300. He didn't have it made.
Really?
Yeah, they had the gears made for that bitch. That bitch got a billet center section in it. Damn. Billets and what you got in there reading? I don't know. I don't care.
He make headers in-house up there?
Yeah.
His shop is in that industrial park that we were talking about right on the...
We got like 8 cars in there right now. I don't want to take that.
All right, so I parted them all off. Brought them all to length, and now I'm going to grind a little tool for the keyway groove, and we're going to rekey them. it says titanium, and I actually use this piece of high-speed steel tool, just ground a little part off and cut it off. It's really not as tough as you might think. Just got to use a slow RPM and slow feed, and it cuts off pretty nice. I'm gonna grind a little carbide tool now for the key grooves, and we'll go ahead and rekey them. All right, maybe you can hear me over this noisy headstock in this lathe. But, took a piece of carbide, a little carbide tool bit, and ground it to the width I want my keeper groove. Got the valve chucked back in there. Got it to the length I want, and now we're just going to go ahead and plunge in and go to the diameter we want for our groove. There you go. Just plunge it in, put our groove, and I'll take a piece of sandpaper lightly and just hit it, kind of deburr that edge up. Use a little sharp edge on the corners. And there we go. We got our keeper grooved in. So there you go. We got all 8 intakes done. Brought them to length. Re-grooved. Now the last step we're going to do here, where I can zoom in on this. You can see where I parted them off. It left a little tit right there. So I'm going to go ahead and put them on the end of the valve grinder, and I'm going to grind that surface. I want that dead flat. So the rocker arm is sweeping across that without any imperfections. And then we'll be done. So we're going to take these over to the valve grinder. And a regular Sioux valve grinder here. And this is just the end working unit of it for facing off the tips of the valves. So I'm going to set one up. I'm going to try to hold this at the same time to show you guys. But, basically, I'm going to bring it into the wheel. Nice and easy. We'll take off a couple thou. And I left a couple thou when I parted it off because I knew I was going to come over here and grind these, finish grind them. Ever so lightly. And there we go. Look at that finish. See if I can show ground nice and flat. 100% contact point. Good to go. It's coming out pretty nice for a little low buck modification here. And again, that's the before and the after. Before the final grind, just the rough part off surface. I know it's so hard to see with the glare. And then the finished ground surface. So just trying to show what I can. I know it's kind of hard, probably the way I'm explaining this. I'm not a good vocational school teacher, but give you an idea of the difference in the ground finish and the lathe parting off. And for those interested on what feeds and speeds, we were doing it. We were parting off at 230 RPMs. All right. So I'm going to finish grinding these up, and then we're going to go over to the exhaust valves. Well, we're finally done. Took me about 3 hours to do the intake and the exhaust. And you guys are probably like, why is a whole lot of effort for a little bit of nothing? Well, I just wanted to come in for a second, run up here to my office, and just kind of show you guys again the reason I'm doing stuff like this. I'm on eBay right now, and I'm just I'll scroll down here to my watch list. So here, if you were going to buy new valves, 11/32 titanium valve plus 600 long, that's what we would need to make it fly with the cylinder head. And as you can see, brand new, we're looking at $1,400. And that's just for 8, okay? So 1,400 times 1,400, times 2, it's 2,800 and some dollars in valves. So and for those that are probably running a pro mod or an alcohol funny car, that's probably not a big deal. But for a poor boy like me, that's unacceptable. So we go back to my watch list here. I just want to show you, and this is what I go through. eBay's your friend when you're a low buck car guy. So here's a set of many that are on here. Titanium valves, 5-inch, 800 long, $100 or make offer. More than likely, you probably get these for 50, 60 bucks. So yeah, so I spent 3 hours cutting, facing them off, re-grooving, grinding them. But in the end, I got some time on a Sunday messing around in the shop, plus $150 I spent for all 16 valves. And the ones I had were Excelodyne brand, which are, top of the line stuff. So just wanted to show you again, that's how we do it. And this is pretty much the only way that I can try to race in this kind of category. Is to do things like this. And just to give you guys a little insight, it's nothing more than an average person can do. Doesn't really take much. A lathe and turn some handles, and there you go. $2,800 to a couple $100, and spend a few hours in the shop. But well, I hope you found the video kind of interesting. Catch you guys on the next one. Guys, have a good week.